Okay, today's lesson is about operations of functions and composition of functions. This lesson is probably going to take two videos, but let's go ahead and jump in and take a look. These first few slides, I just want to give you a look at some different operations. So here's an example of adding functions. So we have f of x is x squared minus 4, and we have g of x is 3x plus 4. So this function notation here, f plus g of x, just is telling you to add f of x and g of x. So you can see it actually worked out here for you. And they separate the functions in parentheses and just add the like terms to get x squared plus 3x plus 1. That's the addition or sum of functions. All right, and then here is an example of the difference of functions. Again, you have f of x and g of x, and you're subtracting them. Now, this is two ways of writing the same thing. F minus g of x is the same as f of x minus g of x. You just need to be comfortable with this function notation. Now, you need to be careful with the subtracting of functions or the difference of functions. When you do subtract, be sure you put your functions in parentheses, because when you subtract g of x, you're subtracting all of the terms. So you're distributing this minus to all of the terms in the function that's being subtracted. All right. And then again, once you combine all the like terms, you end up with this negative x squared minus 3x minus 9 for that one. All right, and then of course we have the product or the multiplication of functions. You see this fg, which means f of x times g of x. So you multiply the functions. This is a binomial times a binomial, so we would need to use what we commonly refer to as the FOIL method, where you're multiplying this x squared times both of these terms, and then you multiply the negative 4 times both of these terms, and combine all your like terms, and you're going to end up with this function here. Okay, and here is the quotient of functions. All right, you have f divided by g of x. That's the same as saying f of x divided by g of x. And then you just work that out, x squared minus 4 divided by 3x plus 5. And then we can factor these out and look for some common factors, and we'll do an example. But also remember, this is our rational function, and your denominator cannot equal 0. All right. Now, this slide shows you the composition of functions, and it is different. This looks like f o g. This is f of g of x. This is not multiplication, okay? So this is f of g of x. So we find g of x, then we plug g of x in, and we find f of what we got for g of x. So we're combining or putting together both of those functions. All right, and we'll get some examples of that. But let's go ahead and start. Here's the, well, this is just, it worked out. But again, this is just the example if you want to refer back to this screen. But we're going to do some practice, okay? So here's some notes that you should have in class. So I'm going to finish this video with just the front side of this notes page. All right, so let's take a look. So first of all, we're just going to be looking at addition, subtraction, multiplication, and division of these functions. All right, so we're just going to fill in this. By the way, I will have this document completely filled out and posted in Canvas as well, but I want to do some with you on this video, okay? So let me zoom in, and let's start with this first one, which is addition. So first thing I want you to notice is this notation here, f plus g of x. So please be sure that you're getting used to this notation, but that just asks you to add. So we'll look up here and we see that the functions f of x is 5x and g of x is x plus 2. So we're simply going to be adding those. So we're going to say 5x, and then we're going to add to that g of x, which is x plus 2. Now, it's always wise to keep these in parentheses. It doesn't matter as much when you're working with addition, but now we're simply going to add these two functions, and we do that by just basically combining our like terms. We have 5x plus 2, so this 5x and x becomes 6x, and then we just have the plus 2. So it's simply 6x plus 2, okay? All right, let's take a look at this subtraction one. We have f of x, or f minus g of x, so we're subtracting f of x minus g of x. Okay, so same functions we're using for these examples, but we have 5x minus, and then definitely put this in parentheses, x plus 2. All right, the reason I pointed out these parentheses is because you are subtracting all of this function. That means every term in this function needs to be subtracted, or we're distributing this minus to both of these. So if I were to write it all out, it would be 5x minus x, and then minus 2. Because we have minus this x, so minus x, and then minus this positive 2, which is really just minus 2. Now, when you do work that out and combine your like terms, basically you get 4x minus 2. 4x minus 2. All right, let's take a look at the multiplication. So this is our f of g, or not f of g, but f times g of x, okay? And let's go ahead and work that one out. I'm gonna zoom my screen in and move it up a little bit. So we have the same functions for all of these examples. We're using 5x, but we're multiplying that times g of x, which is x plus 2. So we're just distributing the 5x to both of these terms. 5x times 1x is 5x squared. Now, if you're not sure where I'm getting this 2 from, this is a review when you multiply variables like an x times an x, and they have that like variable, you add the exponents. This is understood to be an x to the 1 and an x to the 1, and 1 plus 1 is 2. So again, just as a quick review, let's say we had x to the 3rd times x squared. That would be x to the 5th, because we are adding the exponents 3 plus 2, okay? Now, I'm going to go ahead and get rid of that. But returning to this one, 5x times x is 5x squared, and then 5x times 2, that is 10x. So 5x squared plus 10x would be that one, okay? And then over here we have the division, f divided by g of x, and I'm just going to write that one out. So we have f of x divided by g of x, which is x plus 2. And for now, I'm just going to leave that as this just rational function, f of x divided by x plus 2. If we could factor these and then find a common factor to take out, we would, but we're going to leave it like that, okay? All right, so that's those examples. Maybe let's go ahead and take a look at a couple down here on the bottom of our page. I'm not going to do all of them. Again, I do have all of this filled out that I can post to Canvas as well, but I wanted to go over some of it. So maybe we can do the subtraction one. This is a little bit more involved because the functions are a little bit bigger. Now, for time's sake, I'm going to pause the video and write this out. Okay, so you can see here that we have f of x minus g of x. Okay, I put all of that in parentheses. So we're just going to be subtracting any of our like terms. You can see here that we have a 2x squared minus x squared, and then we'll have a minus 5x minus negative 4x, and then finally the negative 3 minus the 3. All right, when we work that out, 2x squared minus x squared is just 1x squared. And then 5x squared minus negative 4x. Remember, minus negative becomes plus. So that's negative 5x plus 4x, which is minus x. And then finally, we have negative 3 minus positive 3, or negative 3 minus 3, which is minus 6. Minus 6. And that's what that one would be. Now for these actually other two examples, number 4 and 5, 4 is multiplication, 5 is division. I went ahead and cut and pasted some notes here, so it's been worked out for you. So with this multiplication, we have to multiply the individual terms of g of x times all 3 terms
of f of x. So this x squared times 2x squared minus 5x minus 3, and then the negative 4x, we have to multiply by all three of these terms, then the 3 times all three of these terms. That's why you see all of these different terms, and then you combine the like terms that have the same base and same variable, and you end up with this 2x to the fourth minus 13x cubed plus 23x squared minus 3x minus 9, okay? And that would be the product of that. Now, over here, quotient or the division, f of x divided by g of x, we have this 2x squared minus 5x minus 3 divided by x squared minus 4x plus 3. We can factor this term right here. And when we factor that, we get these two binomials, x minus 3 times 2x plus 1. Again, if you did the FOIL method of these two binomials, you would get this trinomial. Same thing here. This bottom one, we found the factors of 3 that equaled negative 4. It was negative 3 and negative 1, and that's factored x minus 3 times x minus 1. Now, when we do that, you see that the numerator and the denominator share a factor of x minus 3, so those end up canceling. And your final answer would just be the 2x plus 1 divided by x minus 1. All right? So that is a look at adding, subtracting, multiplying, and dividing functions.